Hi folks, today we're going to talk about permutations. So we're going to get started with a question to kind of open to that topic. In how many ways can Edward, Florence, Cy, Diana, and Brian form a line? And when taking a look at this problem, we essentially have five places they can go to form that line. And with that in mind, we'll have five possibilities in that first position. But let's say Edward happened to be in that first position. Notice Edward couldn't be in any of the remaining four positions. So that means you only have four possibilities for that second position, followed by three possibilities and two possibilities, then one possibility. And this leads us to an answer of 120 different ways they can form the line. However, we have a special notation because this occurs so often in mathematics, and that's a 5 with an exclamation point. That indicates 5 times 4 times 3 times 2 times 1. And we call this 5 factorial. So, to give you an example of how this works in general, you have 7 factorial. That equals 7 times 6 times 5 times 4 times 3 times 2 times 1. Basically, it's multiplication of that number all the way down until you get to 1. The only exception being 0 factorial, and 0 factorial we'll just say actually equals 1. So, keeping this in mind, we actually want to give a definition of a k-permutation. And a k-permutation on a set of n elements is just the different ordered arrangements of a k-element subset from an n-element set, where those number of k-permutations, and this is the big gist, where we can determine that number, and we'll call it p n k, that is given by this beautiful formula where we have p n k equals n factorial divided by the quantity n minus k factorial. And you might see different notations like this mpk that you have indicated up here, but overall this is the formula that we're going to use. So if we wanted to determine the number of 3 permutations from a set of 7 elements, we can carry that calculation out below. So this would be p is 7, 3. Just plugging it into our formula, we get 7 factorial over the quantity 7 minus 3 factorial. And so that's 7 factorial over 4 factorial, or 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by the 4 times 3 times 2 times 1. And so the 4 times 3 times 2 times 1's cancel out, and you're left with 7 times 6 times 5, which is just 210. Okay, so let's try and put this to work in a real life scenario. So determine the number of ways we could select a president, vice president, secretary, and treasurer from a group of 6 people. And the way to do that is actually to, well, we have a couple different methods. We could use our old multiplication principle. And consider you have 4 blanks, and you have the president, vice president, secretary, and treasurer appearing in each of those different blanks. And we have 6 possibilities for that first case, followed by, for the vice president, you can't have the president be both president and vice president, so that would be 5 possibilities for that case. And then that same rule applies, so 4 for the secretary position and then 3 for the treasurer. This gives us an answer of 360. And that was using the multiplication principle, but what we just found is that this is essentially, we're looking for the number of ways we can form a 4 permutation on a set of 6 elements. So that means that we could just write P64 and go through that calculation. So we didn't have to actually carry out all these, the multiplication principle and all that stuff. And this will come in handy later on when we have some large numbers to deal with. So this becomes 6 factorial divided by the quantity 6 minus 4 factorial, which is 6 factorial over 2 factorial, which is 6 times 5 times 4 times 3. And then we can write times 2 factorial instead of times 2 times 1. And so the 2 factorials will cancel in the numerator and denominator, leaving us with 360 as our final answer. And this gives us a nice approach to solving the problems in the future involving permutations.